Hello, I made a self-driving car in Unreal Engine, so it's all made in blueprints, and let's see how it works, and then I'll dive into the details of how it was made. So the car is driving on the tracks, and it should stay on the tracks. So I put traps on in the world to confuse the car. So here there were pebbles. Um, yeah, then there are colored lights. There are T crossroads that the car was not supposed to handle initially, but it works. And this is probably the worst of all of them, the yellow puddle. But yeah, so it handled the puddle. Then there's another trick when the sun goes down, everything becomes sort of yellow orange, so it can be quite problematic. But I'll show you how I handle that. All right, so the car. I'm gonna stop the car, and let's see the setup here. So yeah, the car has a headlight that is physically accurate, so you know we don't get an impossible setup. And the only thing that's driving the car is a little bit of logic and the scene capture component here that renders to a texture just as a camera or a LiDAR would. Um, and all the decisions are based on that texture. So let's look at the texture. That's the texture actually. It's a 50 by 50 pixels image, and this is how it looks. So then after capturing the image on every frame, we're going to try to detect the yellow line. And if it's more to the left of the picture, we're going to try to turn left. If it's more to the right, we're going to try to turn right. And if it didn't find any line, it's gonna go back. And yeah, so let's look at the way we detect the yellow line. All right, so it's a little bit messy, but initially it was much simpler. But with when I added the sunset and the night and day cycles, the car consistently got lost using this single technique. So this is super dumb, but I'm literally just checking if it looks like yellow. If the red value is above a certain thing, if the green value is above a certain thing, and if the blue value is below, it turns out to be that same thing. But that's essentially saying, is this yellow? And if yes, then I'm just saving. Yeah, maybe I should just say what I'm doing. Also, before explaining everything, I need to talk about the constraints. So I'm using a render target, and to read pixel values of a render target, it can be super expensive. I mean, it is super expensive actually. It says here in the tooltip, incredibly inefficient. So I can't read that much of it. Otherwise, it would be much easier. So I decided to just read 1 pixel uh, on the x-axis per. So if the like one line essentially, and that's it. So that's 50 samples at the start. Um, you can see here I'm I'm iterating the x over something, and the y is just a line or a different shape, but we'll see that later. So I'm only doing 50 samples. And then I'm saving these successful pixels in an array. And then I'm getting the average of that array uh, after normalizing it. So if there are more pixels on the left, like here, then I will average out all the yellow coordinates, and it will give me a value that's like, I don't know, minus minus 20%, for example, in this image. And yeah, so that worked fine until I put the day and night cycle. So to solve the day and night cycle, I decided I just had some different ideas, and some of them that I didn't complete actually because it works right now. So my other idea was to get all the pixels, get the average, and sort of get the distance, not really the distance, but how collinear was the current pixel from, no, how collinear is the current pixel with yellow. Yes, and how collinear the current, no, the average is with yellow. Anyway, I forgot what I wanted to do, but here checking how collinear things are. Essentially, to have I wanted to establish like a baseline color and see how close a pixel is to yellow or how close it is to that baseline color, in order to sort of neutralize the sunset orange or yellow color. But yeah, doing that, so initially I had that and it sort of worked. Then I also decided to check the contrast. So if X is 6 times, so if red is 6 times blue and if green is 6 times blue, then we say this is a line, like a middle line pixel. So here there's a last technique here, which is a simplified thing. I'm just taking the current pixel and doing a dot product with the yellow ref, so it's just like 110, putting an enormous power, and just clamping the values to make sure the power doesn't go over 1. Then if it's almost 1, then yes, it's a line pixel. So while I was working, I was actually just doing it blind and just playing, and looking at how the car handled the new settings every time. And then at some point, I decided to actually implement them in a shader, because I could. So here's the texture. Here in red we'll have, so it's white now because it's overlapping, but you can see a little bit of red. Red, we have the first technique where I just check if it's somewhat yellow. Then in green I have the second technique, which is checking the contrast, if the blue channel is lower than the red and the green. And then the last one, actually I was going to implement the thing with the averaging of all values and blah blah blah, but then I just realized that doing a power on the dot was giving me pretty good results. And let's see here when the car drives, and we'll pause when it gets interesting. Yeah. Also, one thing I should note. So initially, I had the software just sample a horizontal line, but then I decided to add some randomness to it. So it was sampling still 1 pixel per X value, but a random Y for each of the 50 samples, from 0 to halfway. I mean, this is not 0. This is 1, but in UV space. But from yeah, it's essentially the bottom lower half of the picture. But then I was getting some trouble with the corners. Not trouble, but it was just useless information. So I just added some sort of a sine wave to sample the thing, so it tries to mimic the shape of the road essentially. And another optimization that I did was to not sample every pixel, so sometimes it randomly skips a pixel. And yeah, because of the performance cost of of reading pixels. So if I had access to the GPU differently, I could read many more pixels. But that, I don't know, that's part of the fun of writing this software. So let's see here. So we only have blue. So blue means the power. So it means that contrast is not high enough, and it's not close enough to yellow here. So it's interesting. Where are we? Okay, so the car is here. Oh yeah, and I also like the lines on the road. They're first of all they're black areas, and also there's noise applied on them to make my life harder. So let's go back. Let's continue. So it's gonna go back and continue the road driving. Yeah. Yeah, here I think we just saw the pebbles. Yeah, I mean we are at the pebbles, but the pebbles are detected with the first technique, the red, but not the others. You see, like, well, it's struggling in the pebbles right now. It's struggling a lot because it can't find. Yeah, and all the techniques they sort of need to agree together, and then we average out their values. Yeah, it's now the car is outside, right? I know it's still here. Okay. Oh yeah, yeah. So the car can get stuck, but rarely will it go randomly outside of the road. Very rarely. So I consider this experiment somewhat a success, and also I wanted it to. It's completely arbitrary, but I wanted it to run somewhat real time, so I didn't uh, read too many pixels. If I read more pixels, then the results become more stable. But I like it where it's sort of noisy. Another interesting thing to note is, as I said, I'm not sampling all the. I'm randomly skipping some pixels, and this becomes quite convenient to make decisions when it goes to an intersection. Like skipping some pixels helps it to go one way or another. If I didn't skip pixels, it would either get stuck or always make the same decision. So like typically here, if I didn't skip some pixels, it would stay at the crossing. And that's, yeah, that's about it. Like let's look at the whole blueprint. So yeah, so I'm, well, it's a bit of a mess, and now there's some redundant code. Like this is useless, so we could do it all in the single loop. But these are cheap. This is the only expensive thing we're doing here. So after that, yeah, we check that we have some pixels in one technique and we have some pixels in the other. Here I just decided to add the pixels to the same array. And if we do, so we sort of agree, then we have, I just take the average of all, and yeah, they're also weighted so that the first technique is this is not the real value, is 0.3. The first technique of detecting like a hard-coded yellow is only 30% of the decision, and then I just normalize the thing and apply, like, add local offset to move forward. There's an ease function to so that the speed is lowered when it turns, and here we add the rotation, so the amount to turn. And if it fails to find any pixels, or like not any pixels but a certain number in both techniques, then it goes again, do another attempt. So this should work. Like with the randomness, it should sample somewhere else and also skip different ones. And if it fails a few times, then the car will drive back a little bit. And actually, like, we could increase that. I think we might get better results. It just looks more choppy when the car does that. Yeah, it's still quite choppy. I also was thinking of adding some temporal information, but since the car is quite stable, like it's choppy, but it doesn't get out of the road uh, despite my attempts to brake it, then yeah, then I don't need the temporal information. I'm just looking at the car because it's very interesting. And sometimes it will go smoothly through things and sometimes not. So maybe I forgot some. I think I disabled like exposure on the camera and global illumination, which I should leave, but it just makes it more expensive and there's no really. I mean, I like global illumination is more realistic, but it does not make it easier or harder. Ooh, the car went a little bit off this time. Let's just see. So here, like in the picture, we see that it agrees that most of the white pixels in the filtered picture are to the right, but it fails to, maybe it doesn't sample them enough to make the call and go to the right, so it stays, remains stuck there for a long time. But yeah, again, these roads were not supposed to exist initially, so yeah, that's my simple system.